we're going to cover today how to multiply or divide two numbers that are presented in scientific notations. So we introduced scientific notation, we introduced its format. We say it has one digit before the decimal point, as many digits as there are after the decimal point, and then multiplied by 10 to the power of something. So that's the representation of scientific notation. That's the format. Now we're going to talk about multiplication and division. So, for example, consider this number, 2.33 times 10 to the power of 7, for example, multiplied by another scientific notation, 9.8 times 10 to the power of, for example, negative 2. How do we do these multiplication? Well, we divide this into two steps. In step 1, we will do the portion that has a decimal. So we normally calculate the multiplication of 2.33 times 9.8. So I open my calculator and put this into my calculator. There we go. 2.33 times 9.8. And I write the result as it is. 222.83 and then 4. So, and then now we have to deal with the tens. So times 10 to the power of. So we have now to multiply 10 to the power of 7 by 10 to the power of negative 2. Now, algebraic rule for that multiplication is that the bases are the same, right? 10 to the power of 7 times 10 to the power of negative 2. The bases are the same, 10. Both bases are 10. So we write 10 in the answer. And then we just sum up the exponents. 7 plus negative 2. That is to say 10 to the power of 7 minus 2. Or 10 to the power of 5. There we go. So we are technically done, but is this answer shown in scientific notation? Remember what was the format of scientific notation? There has to be only one digit to the left of the decimal point. But here we have two digits. We have 22.834. So this is not scientific notation. We still have to convert it into scientific notation. So let's do that. And the process follows the same what we covered in the introduction. So I scan the number from left to right. The first non-zero digit that I encounter is 2. So I write 2. Point. Now the rest of the non-zero digits, I just copy them. So we have 2.2834 multiplied by 10 to the power of. Now we have to figure out the exponent. You notice that we have moved the decimal point from here in the original number, from here all the way to here. That is one position. One position moved to the left, right? From 22 point something, the number turned into 2 point something. So the number has become smaller. We shifted the decimal point to the left. Since the number had become smaller, now we have to make it up in the power of the 10. So 5. It was the original, the power of 10 was 5. Now we shifted the decimal point one position to the left. Now we add that one position to 5, so 10 to the power of 6. Okay? That's how we do it. Very easy. Now let's see one division. Look at this number. 1.188 multiplied by 10 to the power of For example, 12. We want to divide this by 9.9, for example, 9.9 times 10 to the power of negative 9. How about that? Let's see how division is done using scientific notation. It's somewhat similar to multiplication. So the decimal portion of the number, we just put them into the calculator, we divide them normally. So if I open my calculator, you will see. So 1.1188 divided by 9.9, the result is 0.12 times 10 to the power of, now that's the question, what is the power of 10? So here we are dividing two numbers, 10 to the 12 divided by 10 to the negative 9. The bases again are the same. The bases are 10, so the base of the answer is also 10. Since it's division, we subtract the exponents, the powers. So we say 10 to the power of 12 minus 9. When it's multiplication, we add up the powers. When it's division, we subtract the powers. So 12 minus 9. The answer is 10 to the power of negative times negative, that's positive. So 12 plus 9. And the answer is 9 plus 12, that's 21. So 10 to the power of 21. Okay? So we're technically done again. We have the answer. But if they say, represent your answer in scientific notation, is this scientific notation? There is one digit to the left of the decimal point, but that digit is 0. So we want a non-zero digit to the left of the decimal point to have a scientific notation. So we have to convert this one to scientific notation as well, just like we did for the answer of the multiplication. Similar process. If you consider the decimal portion, this is not the scientific notation, so we have to shift the decimal point from where it is in the original number to one position to the right. One position to the right. So from 0.12, the number turns into, if I scan it, right? We scan it from left to right. The first non-zero digit number is 1, then decimal point, and then the rest of the numbers is 2, so times 10 to the power of. So now that we figure out the power, now we look at the decimal point. We shift the decimal point, we shifted it one position to the right. So the number from 0.12 became 1.2. So the number became larger. So we have to make it up in the exponent of the 10. So since we shift the decimal point to the right, that is, we made the number larger, now we made the exponent of the 10 smaller, the power of the 10. So 21 minus how many position we moved it to the right? 1. So 21 minus 1, that's 20. That's it. That's how we deal with multiplication and division of scientific notation. So when you're shifting the decimal point to convert a number into scientific notation, if you shift the decimal point to the left, then you have to add the number of positions that you shift the decimal point, add it to the power of 10. If you shift it to the right, you subtract from the power of 10. Hope you enjoyed it. Let me know if you have any questions.